Is Andrew, and this is a quick overview of what I did for my 287 Data Science 1 final project. So I did bookstore data and class visualization, class relationship visualization. Um, and the main questions I wanted to answer with this project were how much UVM is asking us to pay for books, and also I wanted to do some exploration of the class data and the book data. And I also wanted to start looking at class relationships and building some cool visualizations in the form of networks with those. So my two main sources of data. First, we have the UVM Office of the Registrar. This data is posted for all semesters going back a long time. And it's really great, except it's formatted really horribly. So if we look at what's actually going on for the HTML here, all of this data is one giant pre-formatted block of text that's broken up with href tags every time they want to link something. So there's no tabular structure at all. So what I ended up having to do, this might not be the best way to do it, but what I did is I grabbed all this as one block of text with beautiful soup, and then I placed every word in a column based on its location, its horizontal location, and that's how I was able to sort all this data out. But there are a couple complications. First, there's lots of informational lines like this, which aren't data to be sorted. There's blank lines. There's missing fields. Some of the stuff doesn't line up. Some of the text doesn't line up perfectly. Also, this hang under text here is really annoying because it's not like this line just runs off and it goes right here. If we look, there's a whole bunch of blank stuff over here that we have to account for before we can push all this text together into the column that's supposed to go into. So this was a little bit difficult to scrape, but not too bad. And I put all of it into an Excel document. We have pages for every semester going back 5 years, so 10 semesters. And this is all the data from the registrar. So around 5,000 classes per year, so 50,000 or so rows of data here on my GitHub if you guys want to play around with it for yourself. And after we scraped the registrar data, we went over to the bookstore. This is an interactive web app, so I had to code up a Selenium bug to interact with it. So you select your information in this little drop-down array here. You click add to course list. That gives you your course. You go get your books. It takes you to a new website, and then it gives you an array of your books. I grabbed the price, and then I had to go backwards and then refill out this information and do that over for every single class. So you have to remember where you are in the class tree, the class structure tree here, because it refreshes your entries every time you go back. So yeah, this was a little bit difficult. I'm new to Selenium, so this was a little bit hard to do, but I got it working. Selenium seems to crash randomly just because I'm new, but I couldn't work out all the bugs, so I just ended up writing my code where if one Selenium bot crashed, another Selenium bot would be created at the farthest position that the first one had gotten to. So I would just keep using imperfect bots over and over again. And it ended up taking like 11 bots in like 15 minutes to grab all this data. But once I grabbed it, formatted it, cleaned it up, and I was able to find some statistics. So if we look here, some fun facts. We got $402 being the most expensive textbook. Required. The class of most books is a classics class, which is understandable. Most expensive class was $491 worth of textbooks. And then in total, the school asked students to pay around $4 million, all told, for books. And then the average student spent around $355, which is pretty reasonable, especially when compared to how much the school states that you will need to pay on their website. Next, I took all the UVM class data and combined it into one master class list. So all 10 semesters got crunched into one with duplicates being removed, keeping the newest version of the class. I also removed all classes all entries that are just the same class but different time offerings. And I removed all the entries that had 0 credits, all the entries that had no one currently enrolled in them. I also removed entries that were internships, theses, teacher's assistantships, all that stuff. So cleaned up the class data. And once I did that, I was able to answer some class-related questions here. So the average maximum capacity for a class was 33. Before I did the cleaning, the average class size for students enrolled was 0.1 students per class because there were a lot of just like filler zero classes. So that went up to 23 after the cleaning. So that means that the average class was 70% full. And then UVM posts the data for percentage of classes under 20 students. I found that actually enrolled students, it's 57%. And if you just look at the size of classes stated, max size, it's 35. So UVM's number for that was 40%, so that's right in the middle of that, which is pretty good. And then their stated student-faculty ratio is 18:1, which is pretty close to 23:1, which I found. And then I have some fun facts about the different, not departments, but course types. So the course with the most classes offered, unique classes, was European Studies with 108 different classes offered over the past 5 years. Followed by, these are the top 5 right here. And then some interesting numbers for classes I cared about down here. And then comes the data, the feature engineering. So there's a comment section on the registrar that has all the prereq information here. If we look at it, yeah, here we are. But this was really, really horribly formatted. There was no common structure. It seemed like every teacher was just doing what he or she wanted to do. There were so many different ways to say the word prereq. Some of there were typos everywhere. There were some required classes that didn't exist or weren't offered in the last 5 years. So a lot of cleaning had to be done to get the prereq columns for each class. But once I had those, it was pretty simple to create some edge lists for some networks, and then I popped those into Gephi and created these visualizations of the class flows. So I'm obviously missing a lot of classes and a lot of relationships here, which is unfortunate due to probably my cleaning methods and the very imperfect data that I was working with. But as a benchmark here, this is this computer science classes. This is a benchmark. This is a network that was handmade by the people over at CS, the CS department. So you can see I'm missing a lot of classes and a lot of relationships. But I was pretty happy overall with what I was able to come up with, given that I generated it automatically with data science techniques. So this is the network for the physics department. I'll just move myself out of the way here. So once again, missing a lot of classes and a lot of relationships, but overall, the structure is there and all of these relationships are accurate. And then I did a network for the math department here, this is a lot closer to the actual structure. I was able to capture a lot more of what went into the prereq relationships for math. So yeah, thank you guys for watching, and I hope you guys have a good day. Bye.